This kind of information is fundamental for NASA.
I'm the classic little boy who wanted to grow up and be either a fireman or an astronaut. And the opportunity came up where I could go back to being a little boy and work with NASA and answer a lot of really interesting questions.
There are basically three prongs to the research. The first year's project is to define for NASA a test or a couple of tests that they can use to evaluate the general fitness of an astronaut. When anybody goes to space, there's a profound loss of muscle strength, bone strength, cardiovascular conditioning. Virtually every system that's been looked at deteriorates when we go to space. So the question is, what's the minimum level of conditioning that the astronaut needs to maintain so that when they get to their destination, they're going to be safe? We've set up an obstacle course that includes a lot of the kinds of movements or tasks that an astronaut may be confronted with.
And this kind of simulates things an astronaut might do around kind of the lunar site. So this is where the stairs, the ladder that they ascend and descend come into play, stepping over and ducking under things like getting out a structure or a lunar module.
We contracted with NASA to do up to 110 subjects, and we have probably close to 30 subjects done. One of the things that NASA is very interested in, and so are we, is there a gender sex difference in the way women respond versus the way men respond? As a matter of fact, we want people that are unfit, that don't have a regular exercise program, that they might call themselves couch potatoes. Because one of the things we want to be able to predict is when a person with low physical capacity does these tasks, how does that affect their performance? What we found so far, very exciting, is if we wanted to predict the time that it would take somebody to go through the obstacle course, we can do that simply by making a measurement on the treadmill.
There's actually 4 to 5 tests you can do in a lab where a subject runs until exhaustion on the treadmill at different speeds. And what we showed is that we're actually able to break that down to one test. And then they go to a track and they run as hard as they can for 3 minutes. And just from that 3-minute test, we can get the same parameters as the 4 test, and we can use that to predict performance.
The application of this now is very exciting because that means for all the different things that an astronaut may need to do at their destination, we might be able to estimate their physical conditioning and their preparedness, if you will, to do those tasks with one single test.
I think it also applies to athletes, to patient populations, especially patient populations, just showing if it's hard for them to perform an activity, how can we make that better for them? And so showing that this is a very strong relationship has been surprising and I think also encouraging because we can take it and apply it to different areas.